complementary to data summarization. It is much more efficient to consume information visually than reading the data summaries. Data visualization is such an important part of the business intelligence that data visualization by itself has become an industry. We have several products in the market which are fiercely competing to acquire the data visualization space. In the Python programming environment, there are more than 100 packages for data visualization. We have several very popular prominent data visualization tools like Tableau, ClickView, Power BI, Sisense, MicroStrategy, and many more. In fact, the data visualization companies are way too many that they have used every possible name for starting a company for data visualization, such as junk charts, high charts, etc. Let's look at how data visualization help us consume the data more efficiently. Let us look at this transaction on a credit card. I have taken a small sample of 9 transactions, but let's say we have hundreds of transactions in a month. In such a situation, reading through these transactions and trying to make sense of how you are spending money, how much are you spending on each of the categories, etc., is not so easy. But on the right hand side, if we can represent the data in form of a pie chart, it gives us the information in a single glance. We can quickly see proportion of each of the type of spend. We can also see the total amount spent in each of the category. Let's say $279 in grocery, $184 in merchandise, $200 in restaurant, and $215 in transportation. The time and effort it will take to read through these 9 transactions and try to decipher what kind of transactions in what proportion are happening, it is easier to consume it in a single glance. There is another reason besides this efficiency, is the deception of the data summarization sometimes. So I will show you the Anscombe's quartet. It's a data on 2 variables in 4 different categories: red, blue, yellow, and green. So we have the data on X, data on Y, and we have 4 such sets. If we reduce it down to the statistical summary, each of these sets, these 4 sets, we will notice that the mean of X in all the 4 data sets is 9. Standard deviation or the dispersion is 3.16 in all the 4 data sets. The mean is 7.5 in all the 4 data sets. Standard deviation is 1.94 in all the 4 data sets. And the correlation between X and Y is 0.816. So all the 4 different distributions or different nature of the data are summarizing to the same value. Right? So data summary cannot be completely be relied upon. In such a situation, visually inspecting the data will make sense. Having said this, it is important that we use the data visualization carefully. Now I will walk you through some of the examples of how the data visualization can also be deceiving. Oftentimes the data visualization is used to deceive rather than inform. Let me walk you through some examples. Let us say we are looking at the Canada tax revenue collection in the month of April 25 and May 25. On the left hand side chart, we see there is a significant drop in the collection for the month of May. We perceive it to be significant drop because if we notice the y-axis 0 has been offsetted to $39 billion. Though the difference is very marginal, but it appears substantial. So it is important that we use the right zero level for a comparative analysis of the data. So those who are not careful about noting this offsetting of 0 may think that there is a significant drop in the Canada tax revenue for the month of May. Another way the data can be presented in a deceptive way is by altering the y-axis. It is important that the chart occupies a significant part of the area under visualization. Here we see the inflation has fluctuated between somewhere around 6 and maybe 13 or 14, and we can see that 2021, 22, 23, 24, 25 in last 5 years it has kind of moved in a certain order. But if we increase the scale to a very large value, we won't be able to see those true fluctuations. There is another example that I would like to cite here is the right ordering. This is the chart of 2020 during the COVID times. This table represents the number of deaths and hospitalization in each of those impacted counties. So there are 1, 2, 3, 4, 5 counties. This may give a perception that, hey, because we read the chart from left to right, we notice that the COVID instances are decreasing. But the point is, the person who created the chart deliberately arranged it in the descending order, whereas these should be in the increasing order of the date. So we see that 28th of April is before 27th of April, and then 30th April is after 1st of May, creating this misconception that the COVID cases are reducing. So it is extremely important, and there are ethical considerations while creating the data visualizations.